Excuse me. All right, we're back again. And I stopped early because I wanted to emphasize something on these. So atoms with incomplete outer shells. In other words, they are not full. This is neon. Neon's full. Neon cannot. It has a atomic number of 10, so it's 2 and 8. So the outer shell is full. Here is helium. Helium's pretty small. It's got an atomic number of 2, which means it has 2 electrons. Helium's full. Helium cannot bind with other atoms. It doesn't need to. It's completely stable. These are actually called the noble gases out here. See, this is krypton. 36. So if my math has got me right here, so that's not quite. That's 28. And those almost have complete outer shells, but here's neon. That's an easy one. The next one up would be one that has an atomic number of 28. And it looks like, there it is, nickel. So, because that would be 2, and then 8 would be 10, and then 18 would be the third shell. All right, so here's the golden rule. Atoms with at least 8 electrons, regardless of how big they are or how much they can hold, are more stable. That's the gold. It's called the Octet Rule, O-C-T-E-T, if you want to look that up. And like it says here, atoms have a natural tendency to reach stability, or they want to reach stability. The ones with incomplete outer shells, those are reactive atoms. They can bond with other atoms. And the whole purpose is to try to reach a better, more stable configuration. So here are the different kinds of bonds. You have what's called an ionic bond, which it's showing this electron jumping over. And I can show this a little better. Here is, well, there's that one. There it is. I'm going to make this bigger. Here's an example of an ionic bond. Here is sodium, and this was chlorine over here. I know it says chloride because it's an ion now, but you see 11 protons and you see 17 protons. Sodium has 11 protons, so it means it has 2 in the first shell, 8 in the second shell, and then it's got one little electron hanging out on its outer valence shell, the outer shell. Chlorine was 17, which means it has 2 in the first shell, 8 in the second shell, which is 10, and then it has 7 in its outer shell. And like I said, the golden rule is 8. Atoms that make up people, human beings, animals, they all have 8 electrons in their outermost shells. So that's the whole basis of chemical bonds. And this happens to be what is called an ionic bond. It involves electron transfer. And when this one electron jumps over, let's see if I can go backwards. There it is. See how it's jumping over in this picture? When it does that, now you end up with a situation where there's more protons on this side, more electrons on this side. So here you have a positive charge, and then here you have a negative charge. And negatives and positives have an attraction to each other, and now you have a bond that forms as a result of that. That's called an ionic bond. It's formed from electron transfer. This one is called a covalent bond. You see you have a hydrogen, atomic number of 1, and see how these can come together and they're actually sharing electrons. Now there's 2, so they now have complete outer shells. It can be, you can have bigger bonds than this. You can have multiple atoms bonding as a covalent bond. But that's a covalent bond. And then this is water. Water is a fascinating fluid. Water is polar. And these are called hydrogen bonds, where hydrogen binds to an oxygen or a nitrogen. But the structure of a water molecule, see here's the two H's, there's the O, it's H2O. The way the molecule is structured, one side, the electrons get pulled over to one side of the molecule. So it has a negative positive end, and that actually helps water stick together. Water is polar. Water has something called surface tension. The molecules stick together. That's why those little insects can run across lakes. People can't do that. We break up the surface tension. That's why plants are able to get water up the root system, because the water actually sticks together. So there's a slightly negative end and a slightly positive end. And that really, I'm going to get out of this. That's kind of the three basic bond types. Here's an ionic bond formed from electron transfer. Here's a covalent bond. See here's some bigger ones. Those are electron sharing. And then here you have a hydrogen bond, which, like I said, water is a polar molecule. Now, the last thing here, I'm going to type this. An ion is a charged particle. It's atoms that have gained, or lost electrons. They also go by another name. I was hoping it would finish it for me. Electrolytes. Electrolytes, you've heard of that. Sodium ions, potassium ions. Let me see if I gave you some examples here. There's neon, I gave you that. There's a great one of an ionic bond. Here's water. There's some properties of water. Okay, so what I was going to say, let me see here. Yeah, well, I'll use this slide. See this Na plus and the Cl negative? Those are ions. And this is sodium chloride. When sodium chloride gets released into a solution, it breaks into sodium ions and chloride ions. This is a hydrogen ion. This is hydroxide ions. But ions are charged particles. They either have a plus or a minus sign on them. All right? And the properties of water, I'm going to let you read through this. Kind of went over that. Water is a polar molecule. It can exist as a solid liquid and a gas, which is pretty amazing. It has what's called a very high heat of vaporization, meaning it can actually get really hot before it starts vaporizing. So that's a good thing. It does help stabilize our body temperature. There you go. So high heat of vaporization. But it does stick together, because, like I said, it has a negative end and a positive end. And yeah, anything that is considered in chemistry to be soluble, meaning it can dissolve in water, is hydrophilic. Things that are not able to dissolve in water are called hydrophobic. And they're sometimes referred to as water hating or water fearing. And hydrophilic is water loving. So, okay, I'm going to have 2 more videos for you. I'm going to stop this one here. We'll talk about the pH scale in the next one.